My name is John McClinney. This is a presentation for the Introduction to Cyber Physical Systems class. The paper we'll be looking at today is called ContexIoT, Toward Providing Contextual Integrity to Appified IoT Platforms. The goal of this presentation is to make you understand what that word salad means. The form of this presentation, basically, we'll talk about the paper a little bit, provide some background on IoT and the Samsung SmartThings platform. We'll talk about capability management models, home automation threats, and then the details of the ContexIoT platform. The author of the papers were primarily from the University of Michigan. It was presented at the 21st Network and Distributed Security Systems Symposium in February 2017. And then the background on that word salad from the title. This is basically give you some context for the context. IoT is the Internet of Things. At this point, IoT is more of a marketing term than a technology definition. And the broadest definition is basically it's anything connected to the Internet that isn't a computer, phone, or a tablet. And that's about as narrow as you can get. The particular platform that this paper used for their proof of concept and their analysis is the Samsung home automation system called SmartThings. SmartThings is kind of unique. It was a Kickstarter-funded startup in 2012 that launched their first product in 2013. And in 2014, they were purchased by Samsung. They have become Samsung's primary core IoT platform. Appified is a term I hadn't heard before reading this paper. It basically means any third-party app running inside an IoT or smartphone platform. In this particular case, they're called smart apps on the SmartThings platform. The more general case is something like, iTunes purchased apps running on iPhones. So smart apps in this scenario are small programs that run within SmartThings that basically do something for users and devices, right? They take inputs from users and devices and do something with them. Another term I hadn't heard was contextual integrity, and it's defined in the paper as information flows according to contextual norms. If you read the paper a little bit deeper, what this really means is that the information should flow through the app in the way you expect it and do nothing extra, right? The contextual norm there is if a application is supposed to open a door lock when I press the button, that's all it should do. And the information flow through the application should basically match that behavior. This is a logical picture of the SmartThings architecture. On the lower left, you'll see our physical devices in the home. The two examples here are a door lock and a smart light bulb. They talk over an in-home radio system to the SmartThings hub, which connects them to the cloud. For each physical device I have in the home, I have a logical smart device in the Groovy sandbox in the back end. On the left of the cloud back end, you'll see my smart apps, and that's basically there's a instance of the cloud backend for each user. The permission capability system is the system that the ContexIoT is trying to enhance to move it from a coarse-grained system to a fine-grained system. So as a consumer, what does the SmartThings platform provide me? It provides a robust home automation system which lets me monitor and control my house. From a functional perspective, smart apps get event inputs from smart devices and external systems like my smartphone, and it sends messages based on whatever the application wants to do to smart devices to set their state, in this case, unlock a door. The challenge for securing a home automation system is that I have physical devices. And the risk, of course, is going to vary from household to household based on what devices they have installed, but the highest risk devices are devices like door locks, where I have a physical security risk because someone could remotely unlock the door, cameras which have a privacy risk, and then thermostats which have an environmental risk because someone could turn my heat on or off at the wrong time. Here's a quick overview on smart apps. Smart apps are written in the Groovy programming language, which is a dynamic scripting language that runs on the JVM. They run inside the SmartThings cloud in a sandbox for each user. There's a wide range of applications available as smart apps, from pretty simple to very complicated. In the install time, the user configures a smart app, which is basically a template for some functionality. In this case, if we look at the app at the bottom, we're talking about turning a device on and off at a given time. The user configures that to say, I want to turn on the landscape lights at dusk. And the result of that is it turns on the landscape lights at dusk. What problem is ContexIoT trying to solve? The core concept around the permissions here is that of capabilities. The capability defines a set of commands and attributes for each smart device. So it's what the smart device can do and what its inputs and outputs are. So each smart app can control a certain set of capabilities from these smart devices. And at installation time, basically the user is setting up the application and gives permission to the device to say, this application can use these capabilities for these devices. This course level of control has some issues in terms of securing devices. Basically, I'm only checking this at installation time and not at runtime. And I have to have a high level of trust that the applications will not get hacked. ContexIoT changes this model by looking into smart app behavior at install and at runtime. So it captures each combination of app behavior and capability use into what they call a context. And then each context basically is used to detect bad behavior. And if it is believed to be a valid context, we ask the user to get permission to do that. But we only have to ask the user once, which is an important point we'll talk about later. So the course grading system has a fundamental flaw. It assumes the user understands what permissions are giving apps because the granularity of the permissions is very large. This is basically forcing the user to trust the app developer to be trustworthy, not to be a bad actor themselves, and to keep the code secure and not get hacked. The user has no way of verifying either one of those facts. So a fine-grained system flips that a little bit. It starts doing the monitoring at runtime, and basically each time a new combination of events happens, it asks the user permission. The problem with this is there's too much user interaction, right? The user's getting constantly bombarded with, is this okay, is this okay, is this okay? And they start clicking OK, and you basically have no security at all. So ContexIoT combines the best of these approaches. It looks for patterns of context and patterns of app behavior. It remembers those contexts and it asks the user once the first time it sees that context if this behavior is okay from this app. The user says okay, and the context happens again, we don't bug the user. So we reduce the amount of user interaction substantially. And also, the context is known to match a known hazard. It basically gives me a way of detecting when apps are doing bad things. This combination gives me a better user experience because I'm not bothering the user as much, and also the ability to detect when applications are behaving badly. So what threats are we trying to protect against? So basically we're trying to detect intentionally malicious apps and applications that are behaving badly. So the easy case is the user installed an app that does bad things, is written by a bad actor. The second case here is I had an application that was written by a good person. It was intentionally good, but had a vulnerability that's been exploited. Now it's doing bad things. The third one is trickier. So I have an app that does exactly what it's supposed to do, but what it does is triggered off an external event. In this case, let's say an SMS message. So I send a text message to the application. It unlocks the door. So the vulnerability here is someone spoofs in that message, and then the door unlocks when no one's home. So fundamentally, malicious apps want to hide their bad behavior, right? In a coarse-grained system, they can do that. But in a ContexIoT system, they're going to detect it by detecting, comparing the good and bad context with the current context and detecting what the apps are actually doing at runtime. So let's talk a little bit about the details of what they're doing in ContexIoT. So SmartThings uses the Groovy programming language, which is a dynamic language that uses the JVM. Part of how it works is that the source code is available for all the apps. So the apps are basically compiled and run within the SmartThings sandbox in the cloud. So what the ContexIoT people did was kind of clever and kind of scary, is they actually inserted additional code that they wrote into each app to instrument the app so they could monitor it at runtime. What I don't know is if this was back up. So what is context? We've talked about context quite a bit. So context is a pattern of behavior, right? So basically in this case, it's the pattern of one path through a smart app to the device, to the capabilities of the device. And the thing that they're monitoring here are what they call syncs. And these are sensitive security actions of the smart app. So when the smart app is doing I/O to smart devices, interfacing to external systems for events like unlocking doors, sending text messages, changing set points, those are the things they need to monitor at runtime. They identify those from the static code analysis. So the context basically is developed from the static code analysis and then what they're seeing at runtime. And they're basically looking at the control flow. So is this path through the application different than what they've been through before? They're looking at the variables coming to and from the devices to see if they're within the ranges they expect, right? Since these devices are supplied by SmartThings, the expected values of pretty much all the inputs and outputs are known. So that gives them a way to basically range check and monitor these things. And then data flow. Is the data going to something or coming from something that wasn't seen before? So that combination is combined into a context. So let's look at a real example from the paper. Auto-lock door is a real SmartThing app. Basically, when I unlock the door, if the door is unlocked after some period of time, it'll lock the door again. Basically, functionally, what it does is when it detects a door unlock, which it starts a timer, after that time elapsed, it checks the door sensor to see if the door is closed, because I can't do a deadbolt lock if the door is open. If it is closed, then I lock the door. So what the authors did is they added a backdoor to that code to allow the attacker to remotely use a network command to unlock the door when nobody's home, right? Huge security hole. So ContexIoT can detect the difference in usage pattern, the context, between this normal behavior of locking the door after it's been unlocked and these backdoor scenarios and identify to ask the user what to do. And I can't talk. So here's the smartphone UI for the auto lock door. These are debug screens. They have more information. This is not what a real user would see. So the screen on the left is the happy case, the expected behavior. If you look at what they're doing here, basically, is they want to lock my lock. The event was the door was unlocked. It waited 240 seconds, and my contact sensor, which is saying the door is open or closed, says it's closed. So the request here is to lock the lock, which is what we expect it to do, so the user would allow this. So once they allow this once, as long as the same context and pattern occurs again, they won't have to allow it again. The screen on the right is the backdoor behavior. And if you're looking at what's happening here is this request to unlock my lock, which is like, oh, who's doing that? And the request is from the network. And the mode is away. So this is basically saying, I got a request from the network. I'm not home. And you want to unlock my door? I should deny this. In real life, I would hope that if a context like this occurs, it would also notify the security operations group at SmartThings so they could go investigate this application to see if it's a bad actor or just a hacked application. So one of the other goals of this system, and one of the weaknesses of a fine-grained system is that I may end up bugging the user too many times to get permission, right? So if the patterns of usage, if my context detection isn't very good, I may end up with a different context every time they run the app. I may be asking them every time. It's going to drive them crazy. So what the authors did here, basically, they took 283 of the commercially available smart apps, ran it inside the emulator, and ran it against scenarios where it would be a real user. They measured the average number of times they had to ask the user for permission, and across these apps it was 3.5 times, and that's actually a very good number. It may seem large, 3.5 times 283, but most customers typically have between 10 and 20 apps, not this huge number. And again, once they do the 3.5 times for that app, the odds are you will never bug them again until it's something bad happening. This is a very good trade-off between usability and security, because I am getting better security than I would with a coarse-grained system, but I'm still not driving users crazy. So when a smart app did bad things, how good were they detecting the attacks? So they claim to have detected several attacks that other approaches would miss, and there's a table in the paper talking about the details of that. But basically, they could detect when apps were sending information to a remote attacker. So the case where a rogue app is stealing in-home data and shipping it out to somebody. The other malware case where, let's say an app's doing a door unlock. The normal path is I press a button in my phone, it unlocks the door, everybody's happy. This is the case they can detect from the control flow where I'm getting a network request to do an unlock. So they can detect that. And then if something malware modifies code in an existing app, they can detect that also. Kind of from a architectural point of view, this solution is less intrusive for users. It has less impact on the users, but it's more intrusive for the platform and the applications. They add runtime overhead because they're basically watching each app as it runs to detect the syncs, and also has to inject their tracking code into the app so they can do the runtime monitoring. For heavier duty applications, this might be an issue, but most smart apps are very small and fairly lightweight, and the additional overhead is acceptable in a commercial environment. So the paper demonstrated that this approach is valid. The proof of concept showed that the basic approach worked, that we could detect when applications did bad things. And then when applications were doing their normal behavior, we didn't ask the user for permission too many times. This solution provides a better IoT security solution than is generally available today. It does have currently one limitation. In order to instrument the applications, they need the source code to be available. However, for many interpreted languages, that's not a big issue. They did identify some future research directions. And again, this is basically about providing more information with ContexIoT about the security settings for each app and the context and expected behavior for each context to further reduce the need for the end user to have to interact with the application. As an IoT professional, this approach looks valid. It looks like it's fairly easy to implement and doesn't have a large impact on users. I look forward to seeing their future research and see where they take it. Thank you very much for your time.